Just like any other field, most probably from previous levels of physics, you would be familiar with magnetic fields. Taking a bar magnet, north being there and south being to the right, south pole being there, used to use these flux lines, used to call them, to represent the field. Now these flux lines, in terms of magnetism, were always pointing from north towards south. Why? Because, very quickly, they used to indicate, if they're indicating the path taken by a free north pole, what does a north pole do, a magnetic north do? A magnetic north would be repelled from the north side and be attracted towards the south pole. And those lines with direction represented such a path that would be taken. This would be the same with gravitational fields, but this time around, for gravitational fields, you're going to have the mass at the center. Let's take this, say, to be Earth. And what kind of motion would another mass experience? This mass, if it is attracted to Earth, would move towards Earth in a straight line perpendicular to the surface of Earth, meaning the path taken by that unit mass would be a straight line towards Earth, hitting Earth's surface at 90 degrees. Had the mass been up top here, it would move vertically downwards. Had the mass been here at the bottom, it would be attracted upwards. Had the mass been here, this side to the left, it would be attracted towards Earth also. And this would be the same thing from any point away from Earth, with the direction always being towards Earth. So how do we represent a gravitational field? A gravitational field is always represented by straight lines with their direction towards the other mass. These lines we refer to as the lines of force. And the definition for the line of force in this particular case would be the path taken by a unit mass if it is free to move in a gravitational field, hence the inward direction.